Let's talk first about when to write formulas. One thing you want to make sure that you do is investigate the program functionality first. Let the functionality of Mozaik work for you. And if you have a question about whether your particular situation needs an equation, drop us an email and ask the question. Don't be afraid to ask, and we can point you in the right direction, because there are now a lot of different ways to tackle the same thing, some better than others, with the new custom parameters we've added with your library cabinets and so forth. You can get the same job accomplished in a number of ways. There's a lot of built-in functionality within Mozaik. For example, we've had customers in the past who have written equations to delete parts when really they didn't need to. If we look at the software, in those situations, really all they needed to do was go to the Info tab and check off which parts needed to be built for that cabinet, instead of having to go through the task of writing an equation to delete a part. Writing formulas and equations is actually very simple within Mozaik. We have simplified it. We've put a user interface on the front of it that makes it fairly easy to use. You have probably noticed throughout the software the little calculator. When you see that, that is where you have opportunities to write equations or formulas. If we look back at the software again, you can see the different areas where that's actually available to you. We'll edit this cabinet, click on a part here at the interior view, and we click on the Operations tab. You can now see all the little calculators beside each dialog box. So we can determine, we may want to write an equation for the depth. But one thing you will notice with the equation editor is that the user interface is always exactly the same. This dialog box pops up whenever you click on the equation editor. You'll also notice at the bottom there's an opportunity to view all of the parameters that you can use when writing your formulas. So if we click on library parameters, for example, that will launch the parameters for this particular library, how they're set, and this is the parameter here in the first column that you can use in your equations. So if I were writing an equation that used the bottom rail width, for example, then I would use BR in my equation. If we click on the reserve button, we can see some other nice parameters that we've exposed to you. So if you're writing a formula that's based on the width of the cabinet or the height of the cabinet or the depth of the cabinet, then obviously you can use those. And one reserved parameter that's very important is your good friend Tom. Tom means 2 millimeters. So we actually store everything internally in the database in millimeters, and we expose it to you in inches if you want to see it that way. But it's actually stored in millimeters. So when you're writing formulas, everything has to be converted to millimeters. For example, if I wanted to write a formula that had the height of the cabinet minus 1 inch, if I said h minus 1, I'm going to get the height of the cabinet minus 1 millimeter. If I said h minus 1 times Tom, then I'm going to get 1 inch converted to millimeters. So Tom is your good friend. You need to always learn to use him. Now, where to write formulas? If you've got a cabinet in a job and you need to manipulate a part, there's really no reason to write an equation for that. For example, if in this cabinet I wanted to change something about a part of this cabinet for some reason, I wanted to go into, say, the front stretcher, and I wanted it to be 6 inches instead of 4 inches. There's no reason to go in and actually write an equation for the width of that. I can simply just change its value to 6 inches. Of course, that is, in essence, a simple equation, but there was no reason to base that on the size of the cabinet or any other functionality, because I'm just changing it for this one cabinet. So at the cabinet level, per job, there's really no reason to write equations. If, however, we want to affect the library cabinets, which we want to control the parts of a certain product or the operations that are on those parts, then obviously we want to call those equations up in the library. So we simply click on the library and the products to put us in the product editor for this given library. Then we would call up each individual cabinet and manipulate it however we choose. For example, if in the single door cabinet I wanted to put a 12-inch nailer in the back of that cabinet at all times, then I would simply go to the parts and I would click on the nailer. It's currently 3 inches because our parameter is set to 3 inches. So actually the easiest way to do that would be to go in and invoke that parameter for this cabinet and change its value to 12. Now if we look at that, give everyone's computer time to launch that. Internet connections are at different speeds, so hopefully you're seeing it at this point. Now you can see the 12-inch nailer. And I'm sure that some of you are thinking, well, we didn't really write a formula for that. No, you're right, we didn't, because we didn't have to. That happened to be something that we could accomplish within the normal guidelines of the software. Where a parameter, a custom parameter, or an equation would come into play is if we needed to perhaps change the location of that nailer. It's a 12-inch nailer, but I want it to be placed 6 inches from the top of the cabinet. Then I can go into the nailer, click Edit, and I can go to its 3D part position. And from bottom to top, it's currently located at the full height of the cabinet. I want it to actually be located at the height of the cabinet minus 6 inches. Simple equation. We'll click Test. Always test your parameter or your equations to make sure that you're getting the result you're looking for. Now if we take a look at that product again, now we can see I still have my 12-inch nailer, but it's now dropped down 6 inches from the top of the cabinet. And of course we can use our measuring tool there in SketchUp to check that out. So that's writing equations, if you will, at the product level or in your library. And again, your equations can adjust parts or operations. And we're going to look at a few more examples here at the end of the presentation. And the other way to write equations is on a global basis. In other words, it doesn't apply to an individual product in the library. It applies to all cabinets. So that is the nice advantage of the new custom parameters that have been added to Mozaik in version 3.4. If we click Edit for this job and go into Edit the parameters for this one job and click Custom Parameters, I can now write equations that affect all the cabinets. So for example, if I wanted to add a sleeper for any cabinet that's over 36 inches in width, then in order to do that, we simply go to the Parameter tab and create a new parameter, give it a name, click on Add. And again, this is tab-based wizard, just like all things in Mozaik, so we're working our way from left to right. So once we have the Parameter tab filled out, and of course you can write any type of description here that you'd like, so that if you come back to reference this parameter at some point in the future, you've got lots of notes and you know exactly what to do. We click our product tab and we notice that this product this parameter is being applied for base cabinets and tall cabinets standard, and the size is if the width of it is greater than 36 inches. This parameter is not affected by height or depth, so those aren't invoked in any way. And then we click on the Part tab and we can see that we're adding a part. I gave it a name of Sleeper. I chose its type to be a tow part. It is a graphic part, which means I need to not only define its size but also its graphic location. And now let's look at a few of the parameters that we actually put in place for this sleeper. So if we click on the equation editor here beside the width, we can see the width of that is currently set at the toe height minus or plus the bottom rail minus the bottom thickness minus the bottom interior scribe. Well, how did I arrive at actually writing the equation in that manner? We'll get back and I'll show you that here in a few minutes. We're going to come back to this actual example and go into it in detail. The point that I'm wanting to make to you now is that we can create those parameters globally, and in order to write a formula properly, the first thing you need to do is really write out your logic in longhand or just in simple terms. For example, if we wanted to put a toe base on the back of the cabinet, the part width of that would be equal to what? Well, it's equal to the toe height plus the bottom rail minus the bottom thickness, and I happen to drop my bottoms down below the bottom rail with an interior scribe, so that's the size it would be. And then we convert that to an actual formula using the variables within Mozaik. So if you have something you need to accomplish that's beyond the scope of our normal setup, sit down and write the strategy for exactly what you want to accomplish, and then we'll figure out how to turn that into a formula. That's a good rule of thumb on how to move forward, writing your formulas and equations. The syntax for writing the equations is very simple. Use brackets to set the priorities and just write it out in very simple math. For example, if we had a part that we wanted to modify the quantity of something by 32 millimeters, and we wanted to reduce, we wanted to calculate that based on the height of the unit less 4 times 32 millimeters. Then notice how we have the brackets set here. 4 times 32 millimeters is at the most interior bracket, so that's the first thing that's going to happen in our equation. Then once that number is calculated, then height is going to be reduced by that number. That's the next most part of the brackets. And then the last thing that's going to happen is that final number is going to be divided by 32. So your innermost brackets happen first, and then it works outward from there. And always remember, as far as syntax go, don't forget about your good friend Tom. Everything has to be converted to millimeters. In this example, I'm actually working in metric, so I don't need to convert. But if I had instructed it to do 4 times 1 inch, then it would be 4 inches times Tom, obviously. Hopefully that's clear to you. All right, let's take a look at our first example that we actually want to do. This came to us from Weston Peters, posted on the forum. He wants to actually add a 1/16 of an inch to all of his partitions. So the simple equation to do that, pardon me, is to take a 1/16 times our good friend Tom added to the length of the part. And of course the part type is partitions. So let's go into an example here. Let's take this cabinet and we'll clear out the interior of the cabinet and add a partition. And now let's look at the actual size of that part. If we look at the partition, is currently coming in at 28 5/16. So let's add a formula to extend that. I could do that for this one cabinet by simply clicking on Parts, finding the partition, click Edit, and I could change the length of it here by writing the equation part length plus .0625 times Tom. And obviously, I'm going to put this in brackets, have this happen first. We'll test that, and that will change the length of the part, obviously. Or, if that's something we want to have happen to all cabinets, we can come out to the library, click on Custom Parameters, and now we want to create a new parameter. We'll just call this Adjust Partitions. We're modifying a part in all the cabinets, and the part we're going to modify is the partition. We want to modify its length, and we're going to add 1/16. So we really didn't have to write an equation. We were able to use the custom parameters and just follow the dialogues. Now you could write an equation here in the custom parameters for that if it needed to be manipulated in a different way. Weston, I think you're with us today, so if it were more complicated, the change that you were trying to make, we could click the equation editor and we could actually write the equation for that to be whatever we needed it to be. But in your situation, the user interface here actually covers that equation for you quite nicely. So that will increase the length of all your partitions for every future job. Why did it not affect the cabinet that's already in this job? Because once you start a job, you have job parameters. We just modified the library parameters. So library parameters are for future jobs. Job parameters are for the job that you're currently working on. So to make that happen here, we could write that equation again, or since it's already been written, I can actually go into my library. We can pull up that particular parameter and we can export it. And we'll save it here in the Custom Cabinets subdirectory. And then I can go into the job and simply import it. So now that parameter has been imported. And that one was so easy to write. Obviously, we could have jumped into the job and written it just as quickly, but that gives you an idea of how powerful the import and export can be for you. If you decide to change your construction method, you need to write some custom parameters. You already have several jobs laid out, then you can just create them in your library, export them, and import them into the job. Okay, the next part of Weston's request was to reduce the size of the back by 1/16. So that's very similar situation. We'll actually do that with an equation. We'll go to the job editor and we'll create a new parameter to adjust my backs. We're going to modify a part, and say this is only in the base cabinets. It may be happening, Weston, for you in all situations, but for this example, we'll only do it in the base cabinets and only in the standard base cabinets. And what we're going to do to the part is the length. We're going to adjust the length, or actually I'm going to set the length with an equation which is equal to the part length minus 1/16 times Tom. Simple as that. And again, that in that example, that could have been done by simply leaving it on adjust and typing in an amount there of 1/16 would accomplish the same thing. So the point there is several ways to do things. There's always a best way. So if you have a question about what the best way is, simply email us at support and we will respond to you and get you headed in the right direction. One of the questions always to ask yourself is, where do we write the formulas? And I've got that in each example because that is one of the things you need to think about before you set about writing an equation. Is it a cabinet level for the job? Is it library based on a single cabinet? Is it a custom parameter? Where do we need to write the formula for the most bang for the buck? Of course, you saw this one earlier. We went ahead and did that example when I was explaining things to change the width of the base cabinet. We can go through that again very quickly in this example. We simply click on it, and again we could do this at the custom parameter level, the library level, or here just in the cabinet itself. For sake of time, we'll do it here. We'll take the nailer and edit that, and the width of the nailer we want to be 12. And the 3D position of the nailer from top to bottom, we want that to be the height of the cabinet minus whatever, minus 6 inches, minus, actually we're going to make this minus the stretcher thickness. So let's take a look at that. In materials, the parameter for stretcher is actually the word completely spelled out. So it will be stretcher dot thickness. Put dot thickness to any material name, and that will add the thickness of that part to your formula. So now we're at 34.5 or 34 inches for the placement of our 12-inch nailer. Let everyone's computer catch up to us. Spin that around and you can see the placement is below the stretcher actually. The next example, let's say that we'd like to see a third row of system holes in our cabinets. So let's bring this into play. We'll take a look at an end panel, for example. And we want to add a third row of holes here. So we're going to go to the operations editor. And we'll click on 32mm line bore. Notice that added a third row of holes, but we would like for those to be positioned with the front and back and the quantity to change as the cabinet changes. So if we come down to our table here, we can see the line bores that have currently been done. We'll click over to millimeters for a moment, and we'll see that at 143.1 millimeters is where that starts. How did Mozaik actually calculate the starting position for that line bore? That comes from the algorithms that are written based on your parameters. If you'll notice, this end panel goes all the way to the floor and is notched. So the position of the line bore is calculated at the distance from the bottom of the panel to the first system hole plus the toe height in this situation, because this panel's toe has been extended to the floor. So if you take 4 inches times 25.4 and you add 41.5, which is the location of my first system hole, you'll come up with 143.1. So if I wanted to write a formula that positioned this one at the same place, then in its X position, X is moving in this direction, as you can see. Click on the X equation editor, and I'd like the first system hole to be located at the toe height plus, and what is the parameter that we're looking to use there. This is a nice little parameter list that I will email you after the seminar that we've created in Excel. These are also on the help file, by the way. If you're using the help file, there's hardly anything that we're not going to cover today that's not in the help file, like the equation editor is here. And at the bottom we have a parameter list for the different types of parameters there, which are PDF files that you can print out. So a lot of neat stuff there in help that will help you. So we're looking for the toe height here plus the first system hole, so we'll come down to that category. And our first system hole is 32 millimeter bottom reference is the name of that parameter. So we'll simply add that in. And we'll test that. And we'll put it in place. And now we want to change the quantity of the holes based on the height of the cabinet. So the quantity is here. If I just needed to adjust it, I can adjust it like that. If I want to actually have that be parametric and change as the cabinet height changes, then I can click on the equation editor here beside quantity, and we can write a formula for that. Perhaps we want the number of holes to be the height of the cabinet minus the position of the first hole we know is, let's go ahead and do this. We know it's the toe height plus the 32 millimeter bottom reference. So that calculates a distance, and then we want a quantity here every 32 millimeters, so we'll simply divide that by 32. Test that. Toe height. And so now we've got a quantity there. And you'll notice the quantity of these holes doesn't exactly line up with the quantity of the holes that are automatically calculated. That's because Mozaik and its internal algorithm has determined that if we added another hole here to this line, it would not be functional, so it stops at 22 holes. So if we take this particular set of holes, we wanted to have it match up, then we'd simply take our equation and add one other level, and after the number's been calculated, just subtract a hole from it. And now it lines up with the other holes. So as you can see, your equations can be quite elaborate, but they're very logical. You just need to think through exactly how it needs to be written, research what parameters are available to you, and create that equation. The editor walks you through it quite nicely and allows that to be fairly simple. And so let's move on to our next example. In this example, we will look at adding a part to the cabinet that will come into play as the size of the cabinet changes. So for example, if I wanted to add a sleeper or an additional toe support underneath every cabinet that's over 36 inches wide, well, that requires a lot of different formulas because we have to define the width of the part, the length of the part, quantity, and positioning. So we're going to go out to the custom parameters and we'll create that new part. And we looked at doing this earlier. So we added a part to this cabinet, or actually we've added a part to all base cabinets and all tall cabinets that are a standard configuration. We're not doing it to the corner cabinets. You could also do this to a special named cabinet, which I think I covered that last week. If we wanted to invoke a parameter for just a sink base cabinet or something like that, then you can do that. In this situation, size matters. So as the cabinet gets beyond 36 inches, this part's going to be added. It is a sleeper, which is the name that we've given the part. The type is very important because this defines your materials. This defines the material that part's actually made of. You'll recognize this list of parts here as the same list that you have in your templates, your material template. I'll keep it in the toe kick family so that as the cut lists are sorted and so forth, then it will stay with the other parts. The width of that part, we have that set to the toe height plus the bottom rail minus the thickness of the bottom minus the bottom interior scribe. So that will place it exactly at the bottom of the bottom, which happens to be 5 1/4. If you know that your bottom is always at 5 1/4, you don't have to type that equation out. You could simply type in 5.25 times our good friend Tom, and that would accomplish the same thing. The reason we write it out as a parametric equation is if your bottom rail changes in size, say you go from a 2-inch bottom rail to an 1.5 inch bottom rail on any given cabinet, then the size of this sleeper will change for you automatically, because obviously the position of your bottom is going to change. We look at the length. The length of the sleeper, which is actually going from front to back, so it's being calculated off the depth of the cabinet, and it's the depth of the cabinet minus the toe recess minus the toe thickness, and let's see where that actually is. So we'll test that. So it's going to be a 20 1/4 inch part. The graphic location of the part in the X position, which is left to right, I'm actually adding this to the center of the cabinet, and we calculate the center as the width divided by 2. Very simple math. From front to back, the part's being positioned at the toe recess plus the toe thickness. So in other words, it's being positioned at 3 3/4 inches from the front of the cabinet. And again, if your toe kicks are always that way, you could just enter that as 3 3/4 times Tom and accomplish the same thing. But by making it a parameter and by putting the variables in there, then we give it the knowledge that it can change as you change those parameters. If you were to change your toe recess, your sleeper would adjust automatically. If you change the material thickness your toe's being built out of, your sleeper will change automatically. It'll adjust for that. So that's why we like to use variables as much as possible. And then the Z position, this is sitting on the floor, so Z0 puts it in place. So now let's take a look at this particular example. If we look at this cabinet, let's make it 24 inches wide, and let's go in and take a look at the cabinet. Take a look at our sleeper, which doesn't exist. Why not? Because it doesn't meet the width criteria. So let's change the width of this to 42 inches, and let's take a look at it again. Now we have a sleeper in place, positioned properly, positioned at the toe recess minus the front toe thickness. Puts it right in place exactly where we want it. Now perhaps we don't want it to go the full depth of the cabinet either. We'd like for it to stop where the back stops. So that would be, we would need to reduce the length of that further by the back recess plus the back thickness. So we can go out and add that to our formula. Come back out to Job and go into the custom parameters. Let's look at our sleeper parameter, and the length of that part is now going to also take off the back recess as well as the unfinished back thickness. If we test that, now we can see the length of our part has changed to 19 1/4. And if we go back out and look, we'll see that graphically as well. Now we can see our part now stops at the interior of the back because we also reduced it by back recess and back thickness. One other important thing to illustrate is whenever you're adding parts to cabinets, it's always best if you can copy a part if possible, because a lot of your rotations and positioning information will already be in place. So for example, if we wanted to add a back toe to this cabinet, a very easy way to do that would be to click on Parts, to find the front toe, and to copy the front toe, which gives us the additional part. Then we can click Edit, change the name of the new part to back toe perhaps, and change our 3D part position. Our X position is going to be correct because the back toe is positioned at the same place left to right as the front toe. Our top to bottom position is going to be correct because again it's positioned at the same place as the front. Front to back is going to be different because this is a back toe, so we want to position it at the depth of the cabinet minus the thickness of the part, so minus our toe thickness, and we can take a look at that. So now we've got our back toe in place. So hopefully that's given you a good overview of how the equations work. I'm going to open the floor to questions. I'm going to take about a 2-minute break first, and if you have a question, if you'll simply type it into the chat box, then we will take those individually, and I'll open up each person's mic that has a question. So we'll take about a 2-minute break to get ready for that. Okay, Dennis, your mic should be open. You have a question?
Hey, Roger, how are you?
Doing well, thank you.
I appreciate the webinar today. My question was, I was trying to, I think you somewhat explained pretty much what I did wrong. I was trying to make changes in the editor, you know, when I clicked on the parameters section in the library, and I was trying to make changes for my face frame size and everything, but when I brought the cabinet in, it wouldn't do it. It wouldn't save it. So I'm like, what am I doing wrong? So I think you explained it by clicking on the edit and going to the job.
Yeah, are you on version 3.4 now, Dennis?
Yes, sir. Yep.
Yeah, that was a major change between version 3.3 and version 3.4. We added a level of autonomy to the job by creating a copy of the library parameters and placing them inside the job. So now, if you have a job laid out, if you go to library, products, and parameters, if you make a change, that's not going to affect your job. If you want to change the cabinets that are in your job, then you go to Edit, Job, Parameters. Now you're changing the parameters only for this one job. Does that answer your question?
Yeah, so if I want to change the library itself, then I gotta go through where it says libraries, then go to products.
Correct.
And then go to parameters. Okay.
That is correct. Okay.
So one of the other things I notice when I do that is, could you click on that for me and go to the library and make it like you're going to make a change? Products. Okay, you see where it says method work?
Uh-huh.
You see where it says works method?
Yes.
Well, if I'm in the custom library, how do I change the method that's over there? Mine doesn't seem to change. I don't know how to do that.
This is just a description. So this could be anything you want it to be. This could be...
Mine comes up as basic cabinets.
If you change it to dentist cabinet and you click OK, when you go back to those parameters, it's going to say dentist cabinet. That's just a description. So it has nothing to do with anything other than just a way for you to know what your parameters are set to. So like mine, for example, I had mine set originally to Works method because Works was the name of my cabinet shop. So when I first started playing around with Mozaik, I set up my construction method. Of course now, after supporting you hundreds and hundreds of customers, then there's no telling what those parameters are set to, but that Works method lets me know that that's my method of cabinets. Now you can also save a method. So if you've set up a particular construction method, you can save that construction method by clicking Save As and give it a name, and it'll save it as your construction. And then you can come in and load a construction method as well. When you first buy Mozaik, there are default construction methods that come with it that you can load in by simply clicking on the load and then clicking on the method that you want to load. Okay?
That's what I'm lacking right there.
But those are just examples, Dennis. So, but
Yep.
The title at the top of the screen is just a comment. So I'm going to move on to the next question, if that's okay.
Thanks, Roger.
Yes, sir. Okay, I'm going to move to Michael Dunphy. Michael, can you hear me?
Yeah.
Okay, good. You have a question?
Yeah, I was just wanting to know if there'd be a way to make a parameter so that your upper cabinet would be 1/8 of an inch lower than the actual cabinet, just so it hides the joint between the light rail and the bottom of the cabinet.
Okay, is this a library-based thing, Michael?
It would be for all frameless upper cabinets. So I made an actual library of for just upper cabinets, so I can use those parameters.
Mm-hmm.
But what I'd basically just like to make the reveal, instead of 0 at the top and 0 at the bottom, make it 1/8 of an inch at the top and minus 1/8 at the bottom. But
okay,
I was just curious, really.
Yeah, you can do that with parameters, but like I said in the very beginning, use Mozaik as much as possible. So if you're doing this in a library, then you can call up your library cabinet, you can click on the door, and you can click on the reveal for the top and the bottom. So you could set your top reveal at 1/8, you can set your bottom reveal at minus 1/8, and that will reposition and resize that door accordingly.
Okay,
Yeah,
but now if I was to do that in the actual parameters, I can't put in minus 1/8 because it says
No, that is
I'd
correct.
have to do this for every cabinet in that library.
Yeah, that's why I asked you if
Is
this
that
was a
correct?
library-based
Okay.
situation, because
Yeah.
if you're doing it for your libraries, then you can do it there, right?
Okay,
If
perfect.
you're doing it for all cabinets, then you could come out to your parameters and you could come into those frameless. Oh, notice that, by the way, everyone. Now that I have two different cabinets in this job from two different libraries, when I go to edit job parameters, it now asks me which set I'm wanting to edit, because it's now made a copy of both the custom cabinets as well as the frameless cabinet parameters in this job. So not only do your jobs remain autonomous, but so do your cabinets. So you got a lot of flexibility there. But you could come in to answer your question, Michael, and you could actually modify a part, and the part that you would be modifying would be the door, and you could change its 3D position however you choose to.
If that was a 5-piece door, would it move all 5 at once?
No, it would
Okay.
not.
And then here's one other quick question while I got you here. If you were adjusting the nailers down, if there's an operation associated with the nailer to the end gable, would they move too?
It would not. It would
Okay.
not, because you're only, remember, when you're at the parameters and you go to modify something. So
Yeah.
if I click that, I'm modifying, we'll say those partitions. I'm modifying a part. That's what this parameter does. If I also needed to modify the operations that go with it, I would set up a separate parameter and I would modify operation to do that. So
Okay.
with flexibility comes a little bit of complexity, but everything going well with you in your shop?
It's coming around here.
Good.
Little,
any other questions?
Crazy. Nope, that's good.
Okay, very good. Thank you, sir. I'm going to move to the next person. For the other customers that don't know Michael's shop, unfortunately, we had a fire there very recently, and they were installing a new CNC router when it happened. So not only did they lose their shop, but obviously they weren't able to put their new router into play as quickly as they'd like. So that was a shame. But we are moving on, and I think Michael and those guys have set up a temporary location, so that's great for them. Fires do happen. Unfortunately, in our business, they're fairly common. One thing that we put in place fairly recently, we added a backup location for our customers. I don't know if you've seen this on the forums or not. Let's see if I can get this forum to work for me. If you would like to email a job to Mozaik for backup, just email a job and click all of those boxes, and we will keep it on file for you. So when you go here to File, Email, click all of this information, and that will send us a copy of your job, and you can email that to backup@mozaiksoftware.com. And we've actually created a separate mailbox for that within our GoDaddy account. So we will keep that in a folder for you. Then if you ever had a situation where you had a computer crash or a fire, or for whatever reason you needed to have access to your parameters, just drop us an email and we will send that email back to you that has all your information in it. Kind of off topic there, but I thought worth covering for you. Any other questions? Okay, I'm going to open all the mics up for any conversation that you guys might want to have, and then we will conclude the meeting. We ran time-wise, we did very well today. We were 46 minutes on our 45-minute presentation, and we're now 12 minutes into our 15-minute discussion. So I'm going to unmute everyone. Anyone else have any questions or comments? Everyone's mic is now open. All right, very good. I appreciate everyone being with us. If we can help you, give us a call. Thank you so much. And hopefully this seminar will be up online for you to review it in the future. Thanks a lot.
Thank you, Roger.
Thanks.